In today's lecture, what we'll be doing is we'll be trying to solve a few problems based on what we have learned in the last lecture. So, in the last lecture, we have learned about the load duration curve as well as about different factors. So, in this lecture, this is the first problem. It says that we have to draw the load curve for the data given here. So, this is the time. So, this is the time and this is the load based on different time slots. So we have to find out the first we have to draw the load curve for this. So for that, so let's say it is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then 22, and then 24. And here maximum is going 100. So let's say this is 20, and then this is 40, then 60, then it is 80, and then let's say it is 100. Now for 6 up to 6 hours here the load was 30. So somewhere here, so let me take different pen. So this is the one. Then from 6 to 10, the load is 70. That means in between. So first removing this and then this. Then from basically it was 70. Sorry, it should not be here. Should be below. So this is what the 70 is. This is the one. Then from 10 to 12 the load is 90. So this is 12. The load is 90. So this is the one. Then from 12 to 16 the load is 60. So this is 16. The load is 60. So this is the one. Then from 16 to 100, 16 to 20 the load is 100. So 16 to 20 the load is 100. So here. And then from 20 to 22 it dropped down to 80. So this is the one. Then from 22 to 24 the load was 60. So this is basically the 60, I think. So now this is what the load curve is. Now the task is to find out the first part is over, then to find out the load factor. So what was load factor? So if you remember, the load factor was represented by M, and it is basically the ratio of average load to that of the peak load. So the average load is evaluated as the area under this particular curve, this one, divided by the total time. So if you try to find out the area, so if you look here, that this is 30, then 70, then 90, then this is 60, then 100, then 80, then this is 60. Okay, so the average load will be the power generation. So that is nothing but 30 into 6, because this is for 6 hours, then 70 into 4, then 90 into 2, then 60 into 4, then 100 into 4, and then 80 into 2, then 60 into 2, and this whole will be divided by 24. So this value will come out as 1560, and when divided by 24 will return 65 megawatt, because the load is in megawatt. This is in megawatt. Now uh, now the thing is the peak load. What is the maximum load? This is the 100. So this will be the average load divided by the peak load. So the load factor will come out as 0.65. And this is 5. Okay. Now the question says that, if you look here, it says what is the load factor of a standby unit of 30 megawatt capacity if it takes up all the load above 70 megawatt. Now if you look, this is the 70 megawatt, and above this everything has been taken up by that 30 megawatt standby unit. So this is the one, this and this. So this is 70. So above this is 90. So 90 minus 70 will be 20. Okay, so 20 megawatt is here. Then 100 minus 70, that is 30 is here. And then 80 minus 70, that is 10 is here. So this is basically the load taken up by that 30 megawatt unit for different times. So what is basically the power generation then? So this will be 20 times for how much time? 2 hours. Then 30 for 4 hours. Then 10 for 2 hours. So this is the total amount of power generated. So this will be in megawatt hour. So if I divide it by total time, that is 2 plus 4, 6 plus 2, 8. So that is basically the average load on that 30 megawatt unit. So if you solve this, so this will come out as 180 megawatt hour divided by 8. So this will be 22.5 megawatt. Now the load factor has been asked. So the load factor. Okay. So the load factor M for this unit will be 22.5 divided by the peak load, and the peak load for this particular unit is nothing but 30. So divided by 30. So this will come out as 0.75. So in this way, with the help of the knowledge of different factors, you can solve for or evaluate the different type of factors. Let us take one more problem. Let's say the peak load on a power plant, the peak load on a power plant is 60 megawatt. The loads having maximum demands of, oh sorry, where it has gone. The loads having maximum demands of 30 megawatt, 20 megawatt, 10 megawatt, and 14 megawatt are connected to this power plant. So these all are in megawatt. Okay. Now the capacity of the plant is given to you as 80 megawatt, and the annual load factor on this plant M, remember this is annual load factor, and this is given to you as 0.5. Now you have to estimate the average load on the plant. So what you are expected, let me write it here, the average load, then the energy supplied per year, the demand factor and the diversity factor. So the first thing which we have to evaluate here is the average load. So now we'll be evaluating it from this, that is the load factor, and zero 0.5 is the load factor, and it is defined as the average load to that of the peak load, maximum load, which is 60 in this case. So from here the average load will come out as 0.5 times 60, that is 30 megawatt. Okay, the first part is over. Then the energy supplied in a year. So as you know, the average load, which is 30, so 30 is nothing but energy supplied divided by the time in which energy has been supplied. So it is a year. So that is nothing but 8760 hours. So that will becomes 30 into 8760 megawatt hour. Okay, or you can also write it in kilowatt, so that this will come out as 262.8 into 10 to the power 6 kilowatt hour. Now comes the demand factor. So the demand factor is what? It is the maximum demand to that of connected demand. So what is the maximum demand? It is 60 megawatt, and what the connected demand is? It is 30 plus 20 plus 10 plus 14. So it is 30 plus 20 plus 10 plus 14, and this will give you basically 60 by 74. Okay, and you can solve this. This will come out close to 0.8, roughly. Let's say it is 0.81. So this is also over. Now comes the diversity factor. Diversity factor is basically the sum of the individual maximum demands to that of the simultaneous maximum demands. So demand maximum simultaneously. So this is sum of the individual. So that is 30 plus 20 plus 10 plus 14. That is 30 plus 20 plus 10 plus 14 divided by the maximum one, which was 60. So therefore this will come out as 74 by 60. So it is close to 1.2. So in this way, friends, you can use different factors and solve the problem. So in this lecture, till this point only, thank you very much for watching it.